Okay, so today's webcast is going to be about Markforged, and Markforged is a 3D printer company. To set expectations, this is going to be an overview of what they offer and what what Hawkgrid Systems offers and what we sell. This will take about 45 minutes or so. At the end of it, I'll answer some questions, and then we'll go from there. So this should be fun. Markforged is a really great company. So on today's agenda, I'm going to talk about the digital manufacturing labs, what we do and our purpose, where we're located, some of the Markforged plastic and composite printers, and then we'll jump into the metal printer that's coming up very soon here. Okay, so our first DML was established in 2014. It's in Santa Clara. It's about 4,000 square feet. And the goal is to offer more than just software. The goal is to offer software and hardware and just to meet people's needs. Recently, we've also opened up 2 more locations, one in Bothell, Washington, and one down in Costa Mesa. And this is just to better serve our clients. So this year has been a very exciting year. So what we can do now is we can actually offer new printers. So this year we took on both Markforged and HP. So this just gives us more printers, brings better opportunities to our customers, better ways to serve you guys. So jumping into Markforged here. First we'll do a little bit of a history about Markforged. So Markforged, the company, the founder, he was a MIT engineer. He is also very into motorcycle racing. So you'll notice some of the products that he prints are motorcycle levers and stuff. He is from Cambridge, Massachusetts. His first printer came out in about 2014, and he used to be a machinist. So the first Markforged printer, 2014, this was actually launched at SolidWorks World, and what makes it unique is it could actually inlay carbon fiber. And I'm going to be talking a lot about carbon fiber and trying to better show you the strength and how to quantify how much stronger these parts are, these 3D printed parts are than typical 3D printed parts that you get, or just injection molded plastic ABS parts. In 2016, they introduced the Mark II and then the Mark X in 2017, 2 more printers, an Onyx Pro, and we're very excited that sometime later this year, the Metal X will be released. So the Metal X will be the first metal printer that Markforged makes. Okay, so why should you be interested in the Markforged and what makes it different? So what's great about this is you can utilize Markforged for printing parts that normally would be need to be machined, and it's quite a bit cheaper. So in these 2 graphs here, you can see that the average cost per part was quite a bit cheaper than machining, and the average hours was quite a bit less as well. So what this allows you to do is bring a better part at lower cost to the market faster. For prototyping too, it allows you to make mistakes faster. As an engineer or as an industrial designer, we all know we're going to make mistakes. The goal is to make them as quick as possible before we go to production. And so that's what these parts can do. And with Markforged, we're no longer limited to just prototyping parts. these can be used as end-use parts, which is really, really exciting. So some of the differences between other competitors is one, the ease of use. So the Unicloud cloud software that I'm going to show you later on in this webinar, it's terribly easy to use. It doesn't need to be installed on your computer. You just need to log on. You can see all of your files that you have ever printed. You can reprint them. You can reprint builds. You can share and add other people to your printing group. So if your company is sharing 4 printers in the fleet, you can give access to different engineers and different designers and management, and they can all see what's printing. They can all see what has been printed. They can see different files that have been loaded. You can get print times, all very easily on the cloud. And it's not something that takes a long time to learn. This is about a day or so, and then you click through every single option, and you'll feel good and confident of using the software. The other really nice thing is just the precision and the quality of the parts. If you guys have ever used traditional FDM printers, you know the frustration of having to hit print and doing a prayer that the next day when you come in, it's finished. It's not just spaghetti. Well, with the Markforged printers, that's totally different. You can have confidence that your part will be done and be done well when it's done printing. And that's a big deal. It doesn't sound sexy, but that's really important. When you have a deadline, reliability is awesome. And that's one of the things that these printers deliver is reliability. And then, of course, now we're getting strong parts. And I'll have a lot of graphs to prove that they're strong. This is no longer just a visual model. This is a strong part that you can test with. Okay, so the other thing that we have is the global footprint. So who's buying these printers? Where are they buying them? And so this gives you an idea of where people are buying these printers. So obviously, a whole lot of printers are in the East Coast because that's where they're started. But then you can see they're also branching out to all over California, Europe, Asia, and just even in South America, people are buying these printers. Okay, and then they've actually got a lot of awards for their great products. So it isn't just like a product that was released and no one said anything about it. People have noticed what a great product this is. This is one of the first desktop printers that lives up to the hype and the dream of getting reliable prints off of a desktop printer. Before, not a lot of printers have been able to deliver on that promise or that expectation, and Markforged is one of the companies that are doing this. And here is some examples of what it's great for. So I don't want to put any printer in a box and say this is only what it can do, but these are just some examples to get you excited and make you think out of the box of what it can do. Tooling and fixtures is huge for Markforged. Many companies have found that instead of having to CNC out a tool, a fixture, for their, they can just 3D print that fixture on the printer so that the CNC can just be running and cutting metal and making money, while the 3D printer is printing the cheap, easy fixtures. So that's a great way to save money and utilize the printer. The other ones are working prototypes, of course, that makes sense. And then end-use parts. Remember I said that the founder loves motorcycles, so he built brake levers, metal printed brake levers. He built carbon fiber inlaid brake levers. You can see the sprocket there as well. So really cool uses of 3D printing. Okay, so the lineup that Hawkridge is selling, these are the printers that we are selling. So first is the desktop printer for anyone at any small company, even if you're just a home user. The Mark II is the one that we'd like to talk about and bring to you. So this is a prosumer printer, meaning the quality is wonderful, the prints are reliable, but it's affordable and you can put it on your desktop. It's great for that. The next printer we'll talk about is the Mark X. This is when we jump up into the professional series printers. This one just is made to be ran more, has bigger build volume, has inspection, has all the carbon fiber materials. It's just for professionals. And then very, very soon, we're going to have the Metal X. And this is for production. This is for making end-use parts. This is metal, and we're very excited for that one. Okay, plastic and composites. So this section is all about the plastic and composite printers, the first two I talked about. All right, so this is one of many graphs that I'm going to show you. And so what are we looking at here? So we're looking at the strength of some different materials. The first one is nylon. And so we can see that it's not as strong as ABS. And then onyx. What the heck is onyx? Onyx is the material that Markforged prints with. That's their base material. Every plastic printer that Markforged prints is usually with onyx. That's the base material. Sometimes they inlay carbon fiber or different material inside of it, but onyx is always going to be the outside material. And if we look at this graph, we know that it's stronger than ABS and it's stronger than nylon. So even if you're just printing with a base material, you know that you get a stable, strong material. And how does it achieve this? It actually has chopped up carbon fiber strands within the onyx material. What's great about that is it reduces the amount of working. If you've ever printed with ABS or nylon, one of the things you know is there's a high potential for long, flat things to warp. That's because of how much it changes shape when it expands and contracts. The nylon, because it has, or the onyx, because it has that chopped up carbon fiber, it doesn't expand and contract as much, so it holds its strength a lot better. And that gives you better looking parts, and it gives you more reliable prints, and it's just a superior material. Okay, next graph. So the other thing that Markforged is known for is being able to put in continuous fibers within the part. So what does this mean? This means that you can have an onyx part with inside of it, if it's big enough to put this carbon fiber in or fiberglass, you can inlay continuous strands. So over here, we have a picture of the actual part. Then this would be a picture if we cut it in half so we could see the layers. You can actually see layers of the carbon fiber going across. And then this is a digital representation. So the white lines would represent the onyx material inside here and around. And then the blue lines would represent the inlaid material, either carbon fiber or Kevlar or fiberglass. So you could inlay different materials within your part, and that can add to the strength of it, and it will make it quite a bit stronger. How much stronger? So what we have here is another graph that shows its strength. So if you inlay with Kevlar, you can see the strength. What's nice about this one is it doesn't fail in a dramatic fashion. It starts to yield, and then it just goes off slightly. And what would this be great for? Something that needs impact resistance. So if you're 3D printing a part and you know it's going in a rough environment and it needs to have some flex, but it needs to be strong as well, Kevlar would be a great choice. But let's say that you need something stiffer. You could go to fiberglass, and you can see fiberglass, the CFF is a little bit stronger here. The next one we have is a high temperature fiberglass. Then the next graph here we have is carbon fiber inlaid. And if you notice, it is very close to the same strength as aluminum. So what's amazing about this is that you can 3D print a part and it can have the same, almost the same strength as aluminum from a 3D printed part. That's pretty amazing. This hasn't been possible before, and this gives the user a lot of abilities to make stronger parts from a material that didn't exist and a manufacturing way that didn't exist before. It gives you freedom to make really strong parts that you used to not be able to make. Okay, so more grass. I like grass. So this has now all the different materials. We have nylon down here. We have ABS and onyx. So that's the base material of the Markforged printers is the onyx. Then we have the Kevlar. We have the fiberglass. We have the high temperature fiberglass. We have carbon fiber, and then as a reference material, we have that aluminum as well. So this is game changing for 3D printing. Before, we couldn't 3D print parts that were not at all this strong. And so that means it can open up many different applications for these types of 3D printed parts. And we'll see if this actually plays here. So what this is the center part here is a 3D printed part, and it's actually going to fail, but they're adding pounds to it, and it fails about 21,000 pounds. That's how much force it can hold before it actually breaks. And this is on a 3D printed part, which is pretty amazing. And so if we look up here, 2,100 pounds, 2,200 pounds, you can start seeing it deform a little bit. This one is actually inlaid with a carbon fiber, and there it breaks. So 2,200 pounds. So that's really exciting. It shows that you can make very, very strong parts. Okay, so what type of printers can do this? So the Mark II is the first one that we're trying to sell here. And the Mark II, what it can offer is the onyx material. You could just print an onyx. You could also print an onyx with inlaid carbon fiber, or you could print with onyx and inlaid fiberglass, inlaid Kevlar, or inlaid high temperature fiberglass. And there's also a nylon option. The nylon would take the place of the onyx material. So your base material could either be onyx or nylon. But again, onyx is a stronger material. It's a superior material. So really, I don't see anyone using nylon any longer. The next question is, okay, I like the size. I like the size of this. It's a desktop printer. It plugs into the wall. It's Wi-Fi. That's great. How big can I print something? So your build volume is right here. You can print 320 by 132 by 154. That's your build volume. And its resolution is 100 microns. So very nice, easy, easy to set up, easy to live with, easy to print. It can sit on your desk, and it's reliable, very reliable. I love getting prints off these because you hit print, you walk away, and when it's done, not only will it finish, but it will send you an email letting you know your part is done. So you know when to come back to change it out to start another print. Great uses for this: automotive, aerospace, anything custom, and prototyping. The next printer that we sell is called the Mark X. So this one is more for the professional user. The other one was that prosumer. This part is 330 by 250 by 200, so you get a much larger build volume, and that's great. A lot of people need to print larger parts. It can print with all the same materials as the previous printer, the Mark II, but it has some other benefits. One is it prints at 50 microns, so it can print at 100 or 50, so you can print even finer layers, which will give it even better resolution. You have this wonderful sheen when the part's finished because of that small resolution, and now with this printer, it actually has a laser inspection. So what this means is you can set up different layers within the software to actually inspect the part to make sure it's within tolerance. You can go and capture out, you can say at layer 300, I want to do an inspection, and it'll capture what it's printing at that layer. Pretty unique function. It's really exciting to see how this is going to be used. And it also has a webcam. So at any point, even if this printer is in Chicago, for example, and it's printing, if I have internet connection, I could log into the printer and I could take a screen cap and I could see where it's at, and I could see the print being printed, which is really quite interesting and quite fun to do. Okay, So those are the two composite printers that we're selling, the Mark II and the Mark X. This is usually what everyone cares about, and that's understandable. Metal. Metal's not released yet, but Markforged is going to release later in this year a metal printer, and it's going to be very exciting. So this technology, it is called the Atom. So that's short for Atom Diffuse Additive Manufacturing. So it's different than it's different than a lot of other technologies for metal. It doesn't use powdered metal. In the traditional sense for 3D printing, it doesn't have a high-powered laser either. So what it will do is it'll actually print out like an FDM printer, the metal part in a green state, and then you have to put it in a furnace, and it will fuse the part together afterwards. So within that, within the strands that it's printing, there's actually metal within it. And what's amazing about this is it's one of the first affordable solutions for professionals. These are going to start at under $120,000 for the printer, and that is about 3 or 4 times cheaper than any other metal printer out there. Most metal printers are about $500,000, and you need things like nitrogen to suck out all the air. You need a huge room. They're messy. They have powdered metal that can be dangerous. So instead of all that, this is a new solution. This printer could actually be in an office or shop area, and you could be metal printing. Next is some pictures of what it can do. So again, the founder loves motorcycles, so we're going to see a lot of things from motorcycles like the sprocket and this brake lever. But these are dense metal parts that have been 3D printed. Also, within the software that I'm going to show you, you can also adjust the fill pattern. So the fill pattern is inside the part. How do you want to make it 100% dense, or do you want it to be sparse? And so you could adjust it. In the second image, the lower one, you can see the fill pattern here. So this was stopped about 90% of the way, so you could see the fill pattern of this metal print. What's amazing about that is that it allows you to make really light parts. You could have a very sparse fill pattern. You could have it 50% infill, or you could have 25% infill. So the whole outside is still metal, but it'd still be a very light part. And to give you an example of how small you can print, so these are all 3D metal printed parts. And this example here is, this thing's about an inch in its longest diameter. And it printed these threads. These threads did not need to be tapped afterwards. It was able to print these threads, which is pretty amazing too, that accuracy that this printer is going to deliver. And that's going to open up a lot of opportunities for different people with metal printing. Okay, so with metal printing, there is one thing to be aware of, and there's post-processing. With this, so when it's done metal printing, you're going to need to get a washing station, and this would be something that you'd put in a shop area. And that would be to wash off all the binder off the part. So then you're just left with the metal part that you want to center. And then Markforged has also found 2 different centering ovens that you could use. And basically you would buy one or the other based on the volume of the parts that you want to print center. So one's for, if you're only printing smaller parts, you could buy the centering 1, or if you're doing much larger parts, you could buy the centering 2. And so that's just nice. It gives you more options. And the tech specs. Everyone always wants to know about the tech specs. So its build volume is about the same size as the Mark X, so 250 by 220 by 200. It can print down to 50 microns, it's actually a very light printer. It's 150 pounds. In the 3D printing world, for a metal printer, usually they can run, 5,000 to 20,000 pounds for a metal printer. So this is really amazing how light. I mean, that's going to make it easier to install, easier to move, easier to set up, easier to ship. That's all great. And the cartridges are bound powder, so you don't have to worry about powder floating all over. When you have metal powder, it's also very dangerous. You don't have to worry about that. You have bound metal instead, so it shouldn't get messy everywhere. The other things to look here is the materials that are offered. So you have stainless steel. That stainless steel and the 17.4 and the 316 are both going to be released in the fall when the printer is released. And then they're also testing these other materials that are going to be coming out later on. And you can see aluminums, Inconel, tool steel, and even titanium they're working on. So when you get one printer, you'll be in the future we'll be able to print all these different materials. You won't have to get separate printers for each one of these, and it'll be much easier than all of the competitors to change out to a different material. With traditional metal printing, if you wanted to switch from one metal to another, it's a very intense process because it's powdered metal, and powdered metal gets everywhere. And if you want to be precise and get 100% of that metal out, 100% of that aluminum powder, for example, you have to spend a lot of time cleaning out all the printer to get it completely clean so you could switch over. With this type of printer, since it's bound powder, it's going to be much, much easier to switch out. It'll go from a day to maybe an hour or so to switch out metals. So the other thing that I'm excited to show you is the software. The software is really nice. It's really intelligent. So it's a cloud software, no installation on your computer needed. You can get instant print times, you can get cost of material, and let's just hop in this and I'll show you. Okay, so if I look at on the left-hand side, I have different projects I could do. You can make different projects. I also have parts and builds. So a part is something that you bring in like an STL. A build is the total build that you're going to print on. That's a build platform. When I click on a part here, it'll load the part, and this is internet dependent. So if you're like me and you're trying to run a webinar at the same time, you may have a slight bit of lag depending on your internet connection. But if you don't do multiple things at the same time, it loads up really fast. What can I see here? I can see the name of the part. I can see that this is a clone from another user. I can see all the different revisions of this part, which is really nice. So if you have a part that's changing multiple times and you need to go back to revision 3 because that one fit better, you found out that later revisions failed, you can revert back to these older revisions. Very nice thing. Also, if I click here, look at this. This is wonderful. I know how much it's going to cost right now. I know how much time it's going to take. And I know the weight of this part. So really nice software. So that's all on the left-hand side. And the right-hand side, I can see the name of the part. I can choose from cloud slicing or desktop slicing. So if your internet speed isn't the fastest, you can switch over to slicing on your computer. I can choose what printer to print it at. So right now, Hawkridge has 2 printers hooked up to the internet. So I could actually choose to print right now on the Mark II, which I believe is up north, or I could print in Santa Clara with the Mark X. I'm in a different location, and I could send to these printers. I can choose the scale. I can choose the base material. You can choose if the printer is loaded with onyx or nylon, and I just recommend everyone print with the onyx material. It's better than nylon. You're going to have stronger parts. There's really no reason to print with the nylon. Then what's next is I could choose to inlay some fiber. Now the part needs to be big enough, so let's look at this part. If it's not big enough, oh, you can also choose where to print it. You can scale this thing up pretty easily here. So let's make this bigger. That's another nice feature. If it doesn't fit, obviously it'll show you, it'll turn red. So it changes down to 1.2. Okay, so if I want to put in some fiber, I can add fiber now, and I can choose what type of fiber to inlay. Carbon fiber, Kevlar, fiberglass, or that high temperature. Say I want to do carbon fiber. I can also choose the layers that I want to add in. And with this part, obviously I can't fit 240 layers of carbon fiber. What it'll do is it'll put as many layers as possible. I can choose if I want both isotropic or connecting fibers. So it actually gives you this nice preview of the difference between them. And I would actually like connecting fibers. Walls to reinforce. If I click on this one, you can see all walls, outer or just inner walls. And then connecting rings. How many rings should I have? Maybe I just need a couple, or maybe I want a lot. You can adjust all that, which is really nice. Next, if I know this doesn't need supports, I could turn off supports. I could turn off the support angle. I could use a brim. And then fill density, I could choose if I want this part to be less or more filled. Based on their testing, Markforged recommends these settings. They have not seen much strength increase with things over 50% infill. So I always just go with their default. And if I need to make something stronger, I just put more connecting, I just put more fiber, and I don't adjust the infill very much. So what does this do for me? I'll hit save, and we'll actually change the name. We'll call this 2. And this is going to save the part. It's going to upload it to the cloud as this new one. It's also going to slice it. I'm doing cloud slicing while also doing a webinar, and you can see how quickly it's doing this. So that's really nice as well. You can easily go and do something else while you're doing this. Next, it's doing the pathing. So we'll be able to see the pathing after it makes it. And if this is taking a while, I'm not stuck to this part. I can just open another tab, and I can open another Eiger, and I can look at another part while that part's going. So I can go down here, I can change even the users to just me, and I can look at a part that I've already done. And this one's already on the build table, and what do we see here? So I can see that these are the pliers that I have printed. I printed on the Mark X, and I exported the build. So you have 2 options. You can send it wirelessly through the internet to the printer. Since I'm not located there, you could also export it to a USB drive, and you could walk that USB drive to the printer. So if you didn't have your printer on the network, or there's some network issues, no problem. You can just plug it in. Okay, let's look at these parts here. So if I wanted to look at these parts, I can see how much they cost when I click on it, top left. And then I can also interrogate these parts. So I see the cost, but there's also this really nice view called internal view. And what will this show me? So I can actually see how much onyx material I'm using and how much carbon fiber I'm inlaying. So at the bottom, I can see that I have some carbon fiber here, and I'll just click there. And I see some more here and some more here. So this is just basically how many layers and where the carbon fiber is. If I wanted to change this, I could just slide this over, and you'll see that more carbon fiber will be laid. I could adjust the visibility of this too. All sections, just connecting rings. I could turn off the roof and floors. And I can just see all this stuff, all this detail. I can see a 2D view or even a 3D view. So let's look at the 2D view. Now I can actually see the path of this. I can click through here. So this is each layer. These layers here don't have the carbon fiber. When I get to the blue, I can see that carbon fiber. I can make different groups. So if I wanted a group right here, for example, I could make a new group. So with that, use fiber. So now I have a new group here, and I could say what type. Right now, the fiber, I could say isometric, for example, or concentric. I could say the starting rotation, the angle, pause after this layer. What is pause good for? Let's say that you wanted to insert a nut or bolt or something. As long as you design the part correctly, you can pause, put in a nut, epoxy that in, and then print on top of it. You just have to make sure that the print head would not hit that bolt. So if you make a extrusion into the part, you design your part correctly, you can pause it. That's no problem. That's really cool. If using the X printer, you can say scan after layer, and I could choose it to scan this layer. Use fiber, you could turn that on and off. So there's all these really nice options here. You can choose how many rings even. So let's add some more rings. You'll see what it does. And I'll try to fill in as much as possible. And then as I scroll through here, I have all this wonderful details. So it's just really nice to have all this as an engineer or as a designer, have all this freedom to make your part as strong as possible, where you want to make it strong, how to reinforce it. And then you have some really strong parts, almost to the strength of aluminum. And then when you're done, you can hit save, and then this one will start processing. I could go back to that other Eiger one, and here's my part. And I could go into the internal view of this one, and I could adjust all these things. And when I'm ready, I can send it to the printer. So, and then I have two views. I could actually just say print, and I could put it into the printer. When I'm looking at this, I can see that this here, that's not really going to add too much strength, this whole section here. Not really anything. So I could actually turn off fiber there because I don't need any of this fiber here. I could create a new group and turn this on or off. And over here, I can see that this is actually going to add some strength. It's just 2D, so you can see this. So it's adding a layer around the part. Hit print, put on the build, and then I'll show you, I'll send it to a printer. So I'm going to choose the Mark X. This is in Santa Clara. I happen to not be there. I can remotely send this and hit print, and it lets me know details about this. Warning, requires carbon fiber. It's not loaded. I could still add it to the queue. Select printer. There we go. Even let me know it was busy, but print. So now it's letting me know the plastic volume, the fiber volume, and I can add it to the queue since it's actually printing. And here I can see all the different printers, and I can see what they're doing. So we have the trade show printer. Here's some details about the trade show printer. Another thing that's really nice is you can actually rate your parts. So when you're rating the parts, what that lets Markforged know is how well they're doing, the success rate of this printer. And it'll let them know if maybe there's a problem with your printer. What this one is really nice is I can also see what I printed, onyx and carbon fiber, or just onyx. Here I can see there's an image of it too as well. So there's an image. It looks like it was done at night because I can't really see the print. And you can see that all of these parts, the time, the success rate, it's really nice software. Okay, let's go back to the PowerPoint. So that's the part of the software. It's really easy. It takes about a day to learn, and then you'll be an expert at it. Okay, there's another thing that Markforged offers that is quite unique. I haven't seen this with 3D printing, but it's success plans. So imagine your iPhone. You have this really nice iPhone. A lot of people buy the insurance for it, the accidental insurance. That's what this is. This is just like the accidental insurance to keep it just if anything happens, you can get these success plans. And if if anything happens to the printer, you can choose 1 year, 3 year, and if anything breaks, they will go out and fix it for you. They will send you parts. They'll send you instructions on how to change out something. You can get priority support, and there's engineers on staff to help you with this. So Markforged does not just sell you a printer and run. They want to form a representation, and they want to form, what's the right word, a relationship with you, so that you will print and you will continue printing. A lot of people that buy Markforged printers, actually within a year or two, they buy another one because they learn how much this helps their business. Okay, so I have some case studies, and I'm going to have to kind of go fast through these because I've been going for a while now. But so this is the typical one you've seen on their website, but here's some data about it. So they print with the Onyx. That's these parts here, which are the fixtures. The printed parts cost $9 and take about 9 hours to print. To machine these parts, they cost almost $300. It costs 72 hours because they're outsourcing these. That's a huge difference, and you can see how this would pay for itself quite quickly. The next one here is we can see that this part here, which was printed with that legacy nylon material, to print this, it took 24 hours, cost $21. To machine this part out when it broke, it cost $51. With this example here, this would cost $5 to print. The service bureau would cost $22. This is a really good, this is a TV show. You can actually Google this one and see it. But they take a 3D printed part and they take a hammer to it and they try to break it. And so there's a whole TV show and a whole episode about this. And so that's really cool. Let's see, this one, again, they're printing these parts up here with the nylon, and it looks like they're adding Kevlar within it. So the Kevlar is not as stiff, so this gives it some flex, but still is strong. And that's a use for the Kevlar over the carbon fiber. If you need it to have some flex, not as stiff, Kevlar is really nice. And the difference in cost is just outstanding. $84 compared to $1,000. This one is for an RC car. So we can see how much it would cost to print this or to have a machine shop print out this upright here. And here's another one. This is for stamping. So they're stamping out these green parts here. And to print this, it would cost $15. To machine out the same part costs 10 times more and almost 10 times the amount of hours too. So quite a big difference. Again, so with this one, these are wearable items. They break a lot, the landing gears. So instead of having to continue to get these machined out of aluminum, you could 3D print these. They're so much cheaper. If they break, it's not a big deal. Another one here. So you can see quite a bit of customer stories that Markforged has on their website, just to help show you, make you feel more comfortable that yes, this is a good investment. Yes, it will pay for itself. And yes, there's people using it successfully within manufacturing. Geez, I got a lot of them. Okay, so we're almost done here, guys. So the next thing I need to tell you about is the open house. So we have an open house in Costa Mesa on August 11th. And so if you guys want to come down and talk to some of the experts and learn about 3D printing, learn about Markforged or HP, or learn about scanning, you can register on our website. It's really easy. We have events, and you just go down there, register, and then show up. We always have them on Friday so that you can take off work, and then maybe not go back to work, and just start your weekend.